Hello guys, welcome back. In the previous video, we understood how do we declare an array. So basically the declaration is nothing but the data type followed by the array name, then followed by we give the size. So this is how we declare. So now let's see in this video, how do we initialize? So basically initialization works in two different ways. So one way is said to be static and the other way is said to be dynamic. So let's also go for, so one, two other names for static and dynamic. When we say something called static, it is said to be during the compile time. So when you go for dynamic, it is basically said to be the runtime. So let's say what is static compilation? Let's say what is static initialization. So in this static initialization, you go int ARR of 5, you give the values. So the curly brackets are needed for putting multiple values. So let's say 1, 2, 3, 4, 5. So this is how you initialize it in the static form. So now we can say ARR of 0 is holding the value 1. ARR of 1 holds the value 2. Similarly, ARR of 4 holds the value 5. So let's also try to see something much more into the static initialization point. So now here in our given example, we understood that 10, 20, 30, 40, 50 are the values. And we have seen one more example with 1, 2, 3, 4, 5 values. So let's see now one more example. I'll just take size int ARR of size 5. But in this, let's go give only few values. So let's say the first value is 9, second value is 4, third value is 7. So now here, how many values we have initialized? Only 3 values. Then what about the remaining 2 values? So remaining 2 values by default will be 0. So remaining 2 values by default will be 0. Means now if you say ARR of 0, the value is 9. ARR of 2, the value is 7. ARR of 3 as well as ARR of 4, the values will be zeros. Okay. And there is also something like called warning. So where do you get this warning scenario? The array size is, let's say, 5. But if you try to give the elements, more than 5, means let's take that respective scenario over here. So I'll say int ARR of 5 and you're trying to give 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is not an error, but it is a warning. So why? Because you are giving the excess values 6, 7, and 8. The capacity to store is only 5. Means only 1, 2, 3, 4, 5 you can store. These 3 values you cannot store. So these are excessive. That's the reason. So we are not supposed to give the values more than the given size. And we understood if you give the values less than the given size, the values will be 0. But let's say ARR of 5, 947, we got to know ARR of 4, the value is 0. But what if I say ARR of 5? Means we only have the indexes 0, 1, 2, 3, 4. But what is the value at the index 5? We don't know. So that can be 0, that can be 45, that can be any random value. So this random value, we generally call it as garbage values. So means here if I say there are only 5 values, if you try to access something beyond this respective index, all those are said to be the garbage values. So let's try to see the same thing in our online compiler. All right, let's go. Take the size to 5 and let's initialize with 10, 20, 30, 40 and 50. All right, let's try to print the values. Printf %id is maybe let's say ARR of 0. I want to go for ARR of 2, then followed by ARR of 4. So let's run this. Okay, so now I want to print all these values. If I want to print all these values, instead writing A of 0, 1, 2, 3, 4. So why can't we use simple L loop? So we know that the I value indexes starts from the value 0. So you go for int I equal to 0. It goes until where? It goes until the value 4. Means you go for less than or equal to 4. Instead going less than or equal to 4, you can also go until the value 5. So I increased by 1. Or you can go for I++ also. Let's say printf %id. Let's print that with some space, comma, ARR of I. So maybe after these 3 things, let's try to print the next value is in the new line. So let's run this. So you should be seeing the output 10, 20, 30, 40, 50. So apart from this, let's also try to see the values. Percentile D, I will be printing now the address. So how do you print the address? Address of ARR of I. Let's run this. So you got the address. You say 16 plus 4, 20 plus 4, 24. Every time the value is increased by plus 4. So what if I take this value to double? So instead percentile D, you are supposed to go for LF, as the format specifier is LF for double. So this would be LF. Maybe address would be percentile D, that is fine. But as a better practice, every time we want the addresses to be as a positive values, then let's go for unsigned. So giving percentage U. So let's run it. So now if you observe, so 800 plus 8, 808 plus 8, 816. So this is how it works. So when you are working with the data type as double, you increase the value by plus 8. So let's again go back and keep it back to the integer, and maybe for the address we can go for percentage U. And after this, let's also try to print maybe 3 different values of percentage U. So where we would like to see the value of ARR, address of ARR, and address of ARR of 0. So let's quickly see this. So we should be able to see the same value 648, 648, 648. So let's also try to see one more printf, percentage U, and one more percentage U. So where you would like to print ARR, ARR plus 1, ARR plus 2. So let's run this. So if ARR is 512, plus 1 would be 516, plus 2 would be 512 plus 8, which is 520. Maybe if you try to print the values inside that. So percentage D space percentage D, I'll say star ARR star the whole ARR plus 1. Now run it. So you should see 10 followed by 20. And one last thing, let's try to see maybe slash in printf percentile D. Let's print the value of at the index 40. So we don't have the index 40. Let's see that. So you got the value to 0. Maybe once again you run. Okay, once again you got 0. Basically, it depends on the compiler. But maybe if I just say go with the value of size 8. Okay, you are getting the value 1. But we did not keep the value 1, right? So randomly the value is generated. So that's the reason. But now here, if I give 60, 70, 80, now we gave 3 excess values. So we should be seeing some warning. So we have seen the warning saying that excess elements in the array initializer 60, 70, 80 we got, but we got the output at the end. Okay. And maybe what if I try to give less values? Means we got to know already that we would be getting the value 0. So we got 0 at the index 3 and at the index 4. So this is basically the static initialization. This line number 4, we call it as static initialization. So that is all for this video, guys. Thanks for watching. See you guys in the next one.